Hello everyone, my name is Desmond and I am part of the applications engineering team here at Knorr-Bremse Australia. Today I would like to demonstrate our onboard mass management system, which is known as iMass, and it is a solution that we have that provides industry-leading accuracy on vehicle mass data. This system can be incorporated in the existing architecture of our Knorr-Bremse trailer electronic braking system, and therefore it offers an integrated trailer solution combined with an easily retrofittable vehicle display. This system is designed to measure the airbag pressure from the airbags and convert them into accurate mass data. And this process will help fleet operators optimize their payload and therefore reduce their trips. So what makes our iMass system stand out is that it is fully integrated and it works seamlessly with our Knorr-Bremse trailer electronic braking system. It connects directly to the vehicle ECU and trailer via the existing ISO 11992 CAN network that you're familiar with in our EBS socket, which means there will be no extra wiring between truck and trailer, so it's just plug and go. Here we have our driver interface unit, and everything here is hardwired, so it's very easy to use and gives drivers instant access to information such as axle and combination mass. The interface is intuitive and very simple to use, and it even includes displaying electronic faults so that drivers can pick up and run things smoothly. I would like to also point out that the iMass system is certified by TCA under Smart OBM Category B approval. This means that we meet the requirements for high productivity freight vehicle schemes and other local permits. This also means that our system is also capable of communicating information about the combination, such as mass, with relevant telematics devices for the purpose of this Smart OBM compliance. Our system also supports lift axle detection, and it is also road train capable, supporting up to 7 trailers. Because our system leverages off the Knorr-Bremse hardware, it is a very cost-effective, sustainable, and easily retrofittable to both European and North American trucks. So now I would like to demonstrate our system with you. So I'll walk through with you about our interface and how the mass data is being displayed and accessed by our drivers. So before I move on to the demonstration of our iMass system, let me just go through a quick overview on the components here. So what you can see on the board here is all the iMass components that are fitted onto a truck. We'll start off with the ELC ECU here at the top left. This is essentially the brains of the iMass system. It takes in input from the airbags via a pressure sensor, which is connected to the airbags on the drive axles. The data is then transmitted to the ELC ECU, which is then converted into a mass data that will be displayed on the driver interface unit that you can see here. This is installed inside the cab so that the driver has easy access and can see it. So you may be wondering, we're only getting airbag pressures from the drive axles. So how do we estimate the mass on the steer axles? So the ELC ECU will be converting data from the airbags into a mass data. For the steer axles, we have to calculate it, and that's done by calibrating our driver interface unit here. So ELC ECU will be estimating mass on the drive axles, and our DRU here will be estimating the steer axle masses. Moving on to the bottom here, we have a deflection sensor. So prior to every mass reading, we want to make sure that the vehicle is at ride height before we do any mass reading, just because at ride height, that's where our mass readout is the most accurate. So I'll demonstrate later on the DIU what it would look like to be at ride height. And for our leveling valve here, this is not a crucial component for iMass, but it is something that is nice to have because it ensures that the pressures in the airbags are equalized, and that will make sure that will make the calibration process much simpler and will give us a better reading. Moving on to our module here, this is a trailer road train module. This is typically found on a North American truck. It gives us access to the CAN network with the rest of the combination. We have our GPS antenna here, which is connected to the DIU. The GPS antenna is important because it gives us live data on information such as time and date. And that is important for us so that the system can keep track of calibration dates and calibration due dates. So that's the components here I've just briefly touched on. So now I'll move on to the demonstration of our system. So as you can see here, if I move on to the mass readout page, we can see we're prompted with a enter your current fuel level. So the driver or the calibrator will look at the fuel gauge on the dash, estimate roughly how much fuel the truck's got. This is important for estimating the mass over the steer axles. So for this case, I'll just pick 50%. And then here we have to make sure that the vehicle's at ride height. So if I make some changes to the deflection sensor angle here, I can simulate a vehicle that's not at ride height. And this is bad. You can see there's a red text that has become red. And we actually have a fault symbol here that tells you something wrong is going on. So it'd be the driver or the calibrator's responsibility to make sure the vehicle's gone back to ride height before they proceed any further. So anywhere within the green zone is preferable. So let's move on to the next section. So here we can see our truck with the masses over the steer and the drive. We can see that it's roughly 5.6 ton over the steers and 3.5 ton over the drives. We can also see the total combination mass here. And one thing I forgot to mention before is that this handpiece here, and this handpiece is not part of the system at all. It is purely for demonstrational purposes. It is here so that I can easily alter the pressures in the airbags, and this allows me to simulate a loading and unloading situation. So now I'm going to increase the pressures in the airbag to simulate the truck being loaded. Obviously that's not realistic because there's no trailer on top of it to be loaded, but I'll be adding the trailers later. So I'm going to increase the pressures in the airbag now. You can see the mass of the drive axles and the steer axles are being increased as I go up. So for a typical 6x4 prime mover, the max axle mass over the drive is typically around 17 ton. And this mass limit can be programmed into our DIU so that it could show a fault if those masses are ever exceeded. So for this case, we've programmed the drive axle max to be 17 ton. So if I increase the mass over that limit, so over 17 ton, you can see that axle group becomes red in text. So if I enter to see details on this, it will show over mass limit. It is a visual cue to let the driver know to unload and bring it back down to the legal mass limit. So now I'm going to connect So connect to our trailer combination. So I've got 3 trailers set up, 3 trailer EBS units set up on my right here. So I'm just going to connect the EBS plug. And as you can see on the display here, we have the trailers appearing, as well as the last 6 digits of the VIN. So you can easily identify what trailer is being connected. And then similar to the truck, we can see the axle masses of each trailer. And then you can go into each axle group to look at any details about it. If there's any errors, if there's any faults, we can access those information. And that's all I have for demonstration. Thanks for listening. If you're interested with purchasing iMass and getting it fitted to your fleet, please reach out to our truck services expert network or contact our Knorr-Bremse sales representative. Thank you.